Homework 11, gathering and organizing data, video 4, building classes. I feel like in the length of the previous video, the skill of building classes kind of got blurred in there. So I want to go through one more example where the only thing we're going to do is build classes. We're not going to count frequencies, we're not going to calculate relative frequencies, nor convert them into percentages. We're just going to build classes. And remember, the only information you need to build classes for quantitative data is the least value, the greatest value, and the number of classes. So let's take a look at this example. In a quantitative data set, the least value is 30 and the greatest value is 67. Build 6 classes. To build 6 classes, the first thing we need to do is calculate the class width. I invite you to pause the video and see if you can build the 6 classes and see if we get the same answers. If we do, great. If we don't, pay close attention to where we diverge from each other and go, oops, didn't mean to make that mistake. So go ahead and pause the video and see if you can build these 6 classes. Now, if you pause the video, maybe you've just unpaused it. If you didn't pause it and just want to watch it, then, well, you're losing an opportunity to practice and learn from your mistakes. It's valuable information to learn from mistakes. The first thing we have to do is calculate the class width. And remember, to calculate the class width, we just have to take the highest minus the lowest and divide it by the number of classes. And whatever we get, we round it up. The highest value is 67. The lowest value is 30. We want 6 classes. 67 minus 30 is 37. And if you divide 37 by 6, you get 6.16 repeating. Exactly. Don't believe me, put it in a calculator. But we don't use decimals for class widths. We use whole numbers. So, hey, I tell you what, why don't we use this symbol? Very handy symbol when you're about to draw a conclusion, even if it's just in the middle of a problem. Therefore, the class width is what? It's not 6. I know this would normally round down to 6, but if you round class width down, they won't be wide enough to cover everything. So you always round class width up. So we would round this up to 7. Okay, now that we know the class width, we can start building the classes. You start the first class with whatever the least value in the data set is, which in this case is 30. I'm going to move this up a little bit. I don't know why I didn't take advantage of the space above it. Our class width is 7. So let's build our classes. We were told that the least value is 30, so the first class will start at 30. Now, one thing we weren't told is how precise these measurements were, but since they are all whole numbers, we will assume that all the other ones are whole numbers. If we add precision to 1 decimal place, these would be 30.0 and 67.0. That will be important in a moment. Now, you don't close off any class at the beginning, or at least I don't. You open all of them first. Remember, the role of the class width is to tell you what to add to one lower limit to get the next lower limit. So we're going to start the next class at 30 plus 7, which is 37. And the next one at 37 plus 7, which is 44. And the next one at 44 plus 7, which is 51. And the next one at 51 plus 7, which is 58. So far we have opened up 1, 2, 3, 4, 5 classes, but we were asked to build 6, so we need one more. 58 plus 7 is 65. But where do we close each class? What's each upper limit? Remember, to get one class's upper limit, You just take the next class's lower limit and dial it backwards 1 in the last decimal place. Since these are whole numbers, dialing this back 1 means subtracting 1 from it. The previous class ended at 36. Where will the second class end? The second class's upper limit? 43. That's what you would get if you went backwards 1 from 44 in the last digit. And also remember that you can build the upper limits also by adding the class width. 36 plus 7 is 43. 43 plus 7 is 50, which is what it was supposed to be. Take this backwards 1. 50 plus 7 is 57. 57 plus 7 is 64. 64 plus 5 is 71. Notice that we needed that last class to pick up the highest value, so it worked. So building classes isn't difficult, but again, the most common mistake people make is using the class width incorrectly. The most common mistake people make is saying, this one will start at 30, 30 plus 7 is 37, let me put 37 here. No, the 37 goes here. Add the class width to create the lower limits, add the class width to create the upper limits, or just take each lower limit back 1. All right, we'll have one more video. It's another way of processing numerical data called a stem and leaf display.